Yeah. The second problem is now development of surfaces, and we work on problem on pyramid. So we were doing prisms in the last class. Now I will take a pyramid. So the pyramid, let us consider a square pyramid of sides 45 mm and height 45 mm, resting on HB with two sides parallel to VP. So this is the data given for the stage 1 construction, that we call it as part A, and the next part is part B, that is with respect to the section plane. Section plane is perpendicular to VP and inclined at 40 degrees to the HB. So the inclination of the section plane is with respect to the HB, horizontal line, and where it cuts, that is, it bisects the axis. If this word is there, bisects the axis, means the height should be divided by 2, and at the mid height we have to pass the section plane. So let us observe that how the construction will be. So draw a XY line now. Draw a XY line. So now draw a square, true shape of the square that is visible in the top view like this. So now two sides are parallel to XY line. That is the condition given here. So that we have maintained. So now the dimension of this is square 45, square 45. Okay. So name this, call this as A, B, C, D. I am giving you only one set of letters here because this pyramid class will have a apex at the other side. In the top it will have an apex, and the bottom is a true shape, that is a square. So that is why we get only one letters here. So I give A, B, C and D to the corners, and I will find the center of this. So how do we find the center? Draw a two thin lines like this. So when you draw two thin lines like this, you get a point, that is your O1 point. So that will be your O1. So now pyramid apex is this point. So when you look from the top, this is visible like this. So now we will be taking all the vertical lines from this, including the axis line, we will be taking it to the front. So in the problem he has given height as 45. So height is not 45, it is 71. Okay. So I will change this height to 70. So now 45 will be very short. So let us not take 45. Just take the axis line to an height of 70. So height is equal to 70. So now draw this boundary line and draw this boundary line. And also you have to make this bottom line also thick. So now mark the height which you have taken for the axis. The height is 70. We have taken 70. So let us take 70. Okay. So 70. So now A will become A dash here, comma B dash in the bracket. Put that in the bracket because this is invisible, this is visible. Now B and C, B is visible and C is not visible. So this is B dash, comma C dash in the bracket. Okay. So in O1, O dash will be here and O1 dash will be here. We call that as invisible. Okay. So we have done the stage 1, but one important thing is, in case of a pyramid, these lines has to be marked thick. So means it has to come to the apex points like this. If you do not draw this line, so you will not get marks. You have to be very attentive while taking this lines. If it is a pyramid and you have not this line, you will not get any marks sometimes. So that depends upon the teacher also. They can deduct any marks from you. So because when you look from the top, these lines will be visible for the pyramid. Okay. So and this is the boundary. We will darken this portion also here. So this is your stage 1 construction. So now we have done this part A. Now coming to the part B. So you have to pass a section plane inclined at 40 degrees to the HP and bisecting. Bisecting means what? You have to take a half the distance. So half the distance, let us, what is the half distance now for 70 is 35. So let me take 35 from apex and mark one line, and this will be the point of the bisecting point for me. Now at this point I have to draw my section line. So at what degree? At 40 degree. 40 degrees to what? To the base, not to the axis. If it is axis, it will come like this. If it is base, it will come like this. From 0 degree, that is from the horizontal line that you draw from this bisecting point. So you have to mark a degree, 40 degree. So 10, 20, 30 like that. So 40 degree may come like this. So just draw a line like this. So this will be your section line. So if you write an arrow like this will be the retained one. So retained one will be drawn little thicker compared to the other section. Let me draw this more thicker compared to the other one. So this is the line that we have to draw. So we have now drawn the section line. But in case of pyramid, one more important thing is you have to take the true length, check whether the true length is there or not. Now just this line is also inclined, this line is also inclined. So what we have to do is draw a horizontal line from here, from O1, take the compass and put it here, put OC as a distance and draw an arc here like this. When you draw an arc and take that point to the XY line. So and then if you join this line and this line, this line and this line, we call this line as a true length line. This line is referred to as TL, true length line. So this is very, very important. In case of pyramids, you have to check. What is the condition of checking? Check any one of this slant edges is parallel. So in this case, all the four are not in parallel condition. What we do is now draw an horizontal line and take this as a distance and cut an arc to this horizontal line and take the vertical line from there to the XY line. So join this point to the apex point. So this now referred to as your true length line. So true length line in this case will be little bigger than this generator. Okay, so that is, you have to measure that. According to that, about 76.89 or something is there. You have to measure that. So this will be the TL dimension. You have to draw an arrow like this and also specify the dimension here. That is 76.89. Okay. So like this you have to specify the dimension. Okay. So now let us number this. So now A and D are in the same line. There are two slant longer edges here. See, two slant edges, that is OA and OD. But among this OA and OD, OA is visible because observer is here. OA will be closer. So one is visible and the another one is invisible. Let me give a number 1 dash to the visible one, that is for the OA. So then you move ahead forward in this direction. Axis is there, don't number that. Go forward, you will get 2 points here, B and C, that is OC and OB point. So which is visible? OB is visible because it is nearer to the observer. So give 2 dash. So we have done both. Now again, while returning back, you have to number the dotted lines, that is invisible line. OC is invisible here. So for that we will give comma 3 dash in bracket. So this is very, very important. So you move down now, axis should not be numbered. Move down further, there is one more line here, 2 now, OA and OD. Now for that I am giving, that is 4 dash in the bracket. So after giving all the numbers to this, so better you have to transfer this cutting points onto the top view. So when you draw two lines to the top view, this is very important in the problem. You have to draw a vertical line down to know that where it is lying. So this is the one point we were discussing in case of pyramids. So the section points you have to first drop it down to the top view. So that why we are doing this, because we have to mark that and join the lines of 1 to 4 here in the top view, because when you look from the top, as it is like this, you can see both the cutting face and the bottom face together. So we have to represent that in the top view, which is an important thing. So let me drop down like this. So I get a one point here and another point here. So this is a visible, so let me call this as 1, and this is an invisible, so this is at the back, so let me call it as 4. So now similarly, when I draw this point, I can get 2 more points here, which is cutting the slant edges here. So which are those points? One is this and the another one is this. So this point is 2 and this point is 3, which is invisible. So now I get 1, 2, 3, 4 in the top view. So you need to connect this 1, 2, 3, 4 like this. So this will be the connections that you have to represent in the top view also. So taking these section points to here. Once you complete this, the total stage 1 is complete. Before taking the radial line method, you have to transfer these points onto the true length line. Now take this point to the TL line. This is our TL line. This is our TL line. You have to transfer each point to the TL line. Now if I transfer this point, I get 1 dash here, 1 1 dash you can call, and this is your 4 1 dash in the bracket. Means I have transferred these 2 points to this plane. Similarly, you have to transfer this also, 2 and 3 points. So I will get 2 1 dash and comma 3 1 dash in the bracket. Means all the distances I have to take from the true length, not from the respective distances. So that is why we have to do this. This is very important. If you don't do this, your problem will become wrong. So what you have to do is you have to draw an horizontal line from the section points to the true length line. So here we are drawing now to 1 and 4. That 1 and 4 I am representing here. We are drawing from here to here. So that is representing 2 and 3. So now we will be starting the development point. In this pyramid, we can select arbitrarily a point. So that represents your O. And you will be drawing a line in the radial line method, just drawing a line equal to the length of the true length. In our case now TL is 76.89. So we have to draw that much length here and draw an arc here. Draw an arc for the same distance. Let it be a convenient arc for you first. So then we can take it this. So now, as you know, the distance is 45 mm square. Put it at this point and you cut how many parts? 1, 2, 3, 4. It is a square. So you have to cut 4 parts equal to 45 length. So 1, 2, 3 and 4. So once I do that, this is not required for you. This is an extra portion. So you can remove that. Okay. Now let me join this with a thin line only from the O. So from O I am connecting to all these compartment markings which I have done. This is the total connections. As it is a square pyramid, we will get 4 compartments like this. So now my reference point is say A. So this will become OA for me, and the other one is OB for me. Okay, and then OC, OD, like here, back to A. So this is how we have to mark the thing. Now, one important thing is, from the true length line, one is on the line, one is on the line OA. We have already represented here, OA, one is on the line OA. So, one here is transferred here. So, this distance, so that is from here to here is giving our distance. So, this distance, okay. So, this distance you have to take from the compass. I don't know this distance. Let me say X now. So, this X distance will be marked from O because I am taking from here on this. So, for example, let me just approximately take like this. So, I will mark my point here and I represent this as 1. So, that is this point transferred to the true length. From the true length line I am transferring it. So, now I have done this. Next I have to go to 2. 2 distance is this and this now. So, when you measure this and this gives me a 2 distance. Marking for the point 2 this is. So, whatever the distance is there, let me call that as Y. So, Y now 2 is on which line? B. So, 2 is on B. So, take this distance. So, approximately you can mark the same distance and call it as 2. So, now again 3. 3 is on the line C, correct? OB and OC. C is visible. So, on the line C, again one more point 3. One more point 3. You will be marking that also. And coming down here, again the earlier distance X, because 1 and 4 are in the same point. So, same distance which is on D. So, on the D, so let me take this distance and mark it again. So, let me mark it as 4. Back again we are moving to the last point, that is 1. Same distance again, you can mark it and say it is 1. So, when you mark all these points, very important thing is I am measuring the distances from the apex. So, I am marking it from here also from the apex. So, that will be convenient for you. Once if you do that, join this 1 to 2, 2 to 3 and 3 to 4 and back 1. So, you will be getting like this. So, this is the connections which you do it in a straight line. And also you need to draw a straight line here in the case of pyramids, because it is not a circle or a cone, it is a straight edges at the bottom also. You will be connecting this and this, all the A, B, C, D here using a straight line. That is, take your scale and draw a straight line here. So now which is the development part for us? So this part will be now a development sheet that we have to use it to develop the bottom portion of the pyramid. So that I am showing it here for you. This is the development piece. So, this is also referred to as radial line method, because the pyramid and cone we follow the radial method. In pyramid, the true length will be obtained like this. If any one of the slant edge is parallel, then you can take that line as a reference true length line. If it is not, then you will be drawing an arc like this and transferring that, marking a point here and connecting that to O will give you a true length line. Okay, this is very, very important.